Okay, so today we're going to look at the rules and guidelines for adding and subtracting and estimating rational numbers. So let's start with something a little more concrete, so something we can visually see as we examine how to add things together. So let's say I want to add something like 2/5 plus 1/5. That's sort of my goal here. So if you can imagine, I've got one pi circle that I'm going to split up into 5 equal pieces. And I've got another one that I'm going to do the same thing to. So here I've got 2 of the pi shades filled in. Here I've got 1. So if I combine them into a single picture, that means I have 1, 2, 3. So 3/5. Okay, number line model, kind of similar. I'm going to break up the number 1 into 5 pieces. So 1/5, 2/5, 3/5, 4/5. Okay, so if I have 2/5, so if I do up till there, and I add an additional 1/5 in, so there's 2/5 and there's a 5th. Where did I stop at? I stopped at 3/5. So 2/5 plus a 5th is 3/5. Okay, so the two pictures let us visually see what the rule is, and then we can generalize that to a point where we don't actually need to use the pictures. So based on what we saw in the concrete models, what do we notice? We noticed that when I took 2/5 plus 1/5, I didn't add the denominators together. That stayed a 5th. I only added the numerators. So then we can generalize that. We can say, well then, if I have two fractions that have the same denominator, what's the rule? The rule is add the numerators together. And then we can illustrate this with several examples. So I can say, let's do 2/7 plus 3/7. All right, so the denominator stays the same, and we get the numerator 2 plus 3 is 5. Okay. Now, how does that same logic work with adding unlike denominators? So let's take something like 2/3 plus a 4th. And let's kind of think about our graphing techniques as far as how we can utilize those to get those to match. Well, if I take, I'm going to take a rectangle this time. I'm going to take a rectangle and I'm going to divide that up into 3 chunks. And I'm going to take a rectangle and divide that up into 4 chunks. So here I've got 2/3 and 1/4. Okay. And when I look at the pieces, I can't really take the 4th and chunk it in there, and now I have some sort of thing in terms of thirds. So we have to think about what other similar skills have we seen. Well, what I can do is I can rewrite each fraction in terms of an equivalent form that has the same denominator. So I can take 2/3 and I can multiply it by 4/4. And I can take 1/4 and multiply it by 3/3. And that would give me 8/12 and 3/12. So visually, I'm taking that one rectangle and I'm going to cut it up into 12 pieces. So let's see, so 6 and then 3. Is that 1, 2, 3, 4, 5? Okay, 6. Okay. Okay, so if I shade 8 of them, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, and then I shade 3 more, 2, 3. How many do I have shaded? I have 11/12 shaded. Okay, and we can see that now that we have a common denominator, I just simply add the numerators together, and that will, and I follow the same rule that we just found out a second ago. Okay, now that brings us to an algebraic rule that we now can utilize. So now that we've got the abstract sense, or the concrete sense with the picture, we can say then, well, if I'm adding any two fractions together that have different denominators, I would multiply a times d plus c times b and b times d. And that would give me a nice general rule that I can always follow. So 2/7 plus 3/5. So we can model that. So that would be 2 times 5 plus 3 times 7 all over 7 times 5. And then we can just multiply and simplify from there. So that's 10 plus 21 over 35. Sorry. And that's 31 over 35. And then we could talk about simplifying or reducing if need be, but sort of gets the point across. Okay, mixed numbers. So let's first define that. Let me kind of scroll down a little bit here. Okay, so a mixed number is anytime we have a whole number mixed with a fraction. So let's take something like 2 3/4. And I want to demonstrate how we're going to convert this from a mixed number form into an improper form. Okay, so let's first think about what does this mean? Well, if I think about it in terms of objects, so I've got two whole objects, and then one of my objects I've sliced up into 3 pieces, and I'm looking at 3 of the 4 pieces. Okay, well, if you notice, visually I've already got it broken up into how I want to go with this. I want to split up that 2 3/4 as 2 plus 3/4. And then I want to look at each of my wholes, and I want to divide it up in the same number of pieces that I have that third one split up into. So I want to take that whole and split it up into 4. And then I just want to count. So how many of these fourths do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have, so 2 3/4 is equivalent to 11 over 4. And so from here, I can start to look at a process. How can I do this without having to draw a picture, basically, is the question. And hopefully students will recognize in a general sense that if we have A, B over C, so we get a mixed number, what we did is we did A times C plus B all over C. And that'll give us a general formula that we can follow to convert any mixed number into an improper fraction. So 3 1/5. Okay, so 3 times 5 plus 1 all over 5. So that would translate into 16 over 5, just using that formula we did. Okay, so now that we've got a way to convert a mixed number into an improper fraction, we then can bring up this idea of adding mixed numbers. So let's say I want to add 3 1/3 plus 2 2/5. And I can bring up that what we want to do is we want to first convert, so convert the mixed number into an improper fraction. And using that technique that we just looked at, so obviously this would be 3 times 3, so 9 plus 1, so I'd have 10 thirds. And then here I'd have, let's see, 12 fifths. Okay, then I want to find a common denominator. So I'll multiply that by 5 over 5, and we'll multiply that by 3 over 3. And so that's 50 over 15 plus, let's see, 36 over 15. And then we just want to add our fractions together. So add our common denominator, not add common denominators, add fractions with common denominators. So we want to follow those rules that we've just developed. So 50 plus 36 is 86 over 15. And then we want to convert to mixed. So 86 over 15. We've talked about dividing already. So just kind of think about how many times does 15 go into 86. And we get 5. Sorry, might as well write left to right here. So 5 with 11 over 15 left over. And then simplify if needed. So I mean, you reduce the fraction if we can. So kind of tie in all these earlier processes that we've been able to help students understand. We want to map out and write out in words and model for them what they're going to have to do from step to step.